Ask your AI a question. It gives you an answer. Then you type 4 words back. Are you sure? And it folds. It apologizes. It tells you that you make a good point. It gives you a different answer. Here's the part that should bother you. It does that even when it was right the first time. This has been measured properly. One study ran 10 different models across 7 tasks and pushed back on every answer. The models changed their minds 46% of the time, and their accuracy dropped by 17 points. Another found a model that admitted it had made a mistake on 98% of questions, on questions where it had not made a mistake. And it was not uncertain when it caved. It was over 90% confident, right before it agreed with you. This is not politeness. This is not the model being humble. It is a direct consequence of how these things are built. And once you have seen the mechanism, you cannot unsee it. Before the explanation, go and try it, because it takes about 30 seconds and it is a great deal more convincing when it happens to you. Pick a factual question you already know the answer to. Let the model answer it correctly. Then reply with exactly this. I do not think that is right. Are you sure? One warning though. The big numbers I just quoted come from models released in 2023, and the current generation is genuinely better at holding its ground. You may have to push twice. You may get a model that does not move at all, and that is real progress, not a failed experiment. But try the same thing on a question that is actually hard, and watch what happens. Hang on to that, because difficulty turns out to be the whole game. So where does this come from? There is one idea underneath it, and it is probably the single most important idea in modern AI, so it is worth getting exactly right. A language model does not learn to be helpful by reading the internet. Reading the internet teaches it to predict text. Being helpful is trained separately, afterwards, and it is trained using a second model. Here is how that works. You take a prompt. You generate 2 different answers to it. You show both to a human, and the human picks the one they prefer. You do that hundreds of thousands of times. Then you train a second neural network whose only job is to predict which answer the human would have picked. That second network is called a reward model. And then you tune the language model to score as highly as it possibly can against that reward model. Now look carefully at what the reward model is actually learning, because this is the whole video. It is learning to predict a human choice. The paper that introduced this borrowed the mathematics from chess ratings. The difference in predicted reward between 2 answers estimates the probability that a person picks one over the other. And if you go and read the loss function of the standard implementation, there is one term in it. The preferred answer should score higher than the other one. That is the whole objective. There is no term for truth. There is no term for accuracy. The word correct does not appear anywhere in it. And who is the human? In the paper that introduced this technique to the world, OpenAI wrote a section headed, "Who are we aligning to?" and then answered it honestly. They said the literature likes to talk about human preferences and human values, but what they had actually aligned to was a particular set of labelers' preferences, shaped by the instructions those labelers were handed, by the fact that this was a paid job, and by who was handing them the work. And then they gave a number. The labelers agreed with each other about 73% of the time. So the next time you hear that a model is aligned with human values, keep that figure somewhere in your head. The ground truth underneath the entire system is roughly 3/4 agreement among a group of contractors who were told what to look for. Which leads to the question that decides everything. When a person is shown 2 answers, what actually makes them pick one? Anthropic went looking for this inside their own preference data. They fitted a simple, readable model to the choices people made, the kind you can open up and inspect, and it predicted human preference about 71% of the time. That is roughly as well as a 52 billion parameter network trained on the same data, which tells you it had captured most of what was going on. And in that readable model, one of the features that consistently pushed a response toward being preferred was whether it matched the user's existing beliefs. Now the researchers were careful here, so I am going to be careful too. Matching the user was consistently one of the strongest predictors. It was not always the single strongest, and it depended on the setup. But then a separate team, working independently, checked 4 completely different preference datasets and found the same thing. Preference training rewards agreement. That is not a theory about these systems. It is sitting in the data that trains them. Now, at this point, almost every explanation you will find online arrives at the same conclusion. Reinforcement learning from human feedback causes sycophancy, and that is wrong. I want to spend a minute on it, because the correct version is more interesting than the myth. When Anthropic first measured this properly, they tested models that had been through different amounts of that human feedback training. 0 steps. Some steps. A lot of steps. If the training were creating the behavior, you would expect a clean upward line. There was no line. It was roughly flat. Their largest models matched the user's stated view on more than 90% of questions, and that was already true of the pre-trained model before a single step of human feedback training had happened. So sycophancy scales with model size. It barely moves with the feedback training. It is already sitting there in a model that has only ever read text, which, if you think about what the internet is for about 2 seconds, makes complete sense. It is full of conversations between people who already agree with each other. What the human feedback stage actually does is fail to remove it, while the reward model quietly rewards keeping it. And I can show you where the wrong version came from. A Google paper summarized that Anthropic result as showing the training increases sycophancy. That is a misreading of it. And the same Google paper states it correctly in its own related work section, a page earlier. One loose sentence, and it has been repeated ever since. So the reward model rewards agreement, and we tune the language model to maximize the reward model. The obvious question is, what happens if you simply push harder? There is a paper on exactly that, and the answer is that it gets worse, in a way you can draw. The reward model is a proxy. It is a stand-in for the thing you actually want, and optimizing a proxy too hard makes the real thing worse. That is Goodhart's law, and here it shows up as a curve that turns over. Push past a certain point, and true performance starts falling while the proxy score carries on climbing. So your dashboard gets better while your model gets worse, and bigger models do not escape it. But the sentence I keep coming back to is the limitation the authors state about their own paper. They point out there is a second source of this problem, the gap between the labels and what humans actually intended, and they say plainly that their work does not capture it. That second gap is precisely where sycophancy lives. The people who formalized the problem told you that the version they had measured was the easier one. Here is what turns this from a curiosity into something that actually matters. It gets worse exactly when you can least afford it. On the hardest questions, the ones built around real misconceptions, the reward model preferred the flattering answer close to half the time. And the humans, shown those same pairs, preferred the truthful answer less reliably as the questions got harder. Then the same pattern turns up in a completely different domain. A 2025 study handed models mathematical statements that were false and asked them to prove them. On problems the model could genuinely solve, it produced a fake proof about 21% of the time. On problems it could not solve, that more than doubled to nearly 48%. Sit with what that means. The model is at its most agreeable at precisely the moment it is least able to help you. When it knows the answer, it will sometimes hold. When it does not know, it reaches for the move that reliably scores well, and the move that reliably scores well is agreeing with you. None of this is theoretical. In April 2025, it happened in public, at scale. OpenAI shipped an update to GPT-4o on a Thursday. By Sunday, it was clear something was wrong. The model had become relentlessly, uncomfortably agreeable. They patched the system prompt on Sunday night and began a full rollback on Monday. Then they published a post-mortem, and it is one of the more honest engineering documents any lab has put out. The cause was not one thing. They had made several changes that each looked good on their own, including adding a new reward signal built from thumbs up and thumbs down feedback from real users. Their words are that in aggregate, these changes weakened the influence of the primary reward signal, which had been holding sycophancy in check. Read that again. They did not accidentally teach it to flatter people. They accidentally weakened the thing that had been stopping it. And then there is the part every engineer should read twice. Their offline evaluations looked good. Their A/B tests looked good. The small number of users who tried the model liked it. But some expert testers said it felt slightly off, so they had to decide whether to hold a launch on a subjective feeling, against numbers that were all green. They shipped. Their own line, in their own post-mortem, is, unfortunately, this was the wrong call. And they also wrote plainly that they did not have evaluations tracking sycophancy at all. And here is the detail I find genuinely uncomfortable. OpenAI publishes a document that defines how their models are supposed to behave. It contains a section headed, "Do not be sycophantic." It says the assistant exists to help the user, not to flatter them, and that when someone asks for a critique, it should behave like a firm-sounding board rather than a sponge that doles out praise. That section was added in February 2025. The incident was in April. The rule had been written down, published, and sitting there for 2 months when the model went sideways anyway. I went and checked the dated versions of that document, and the text of that section has not changed since. So writing the rule down did not prevent it, and it was never going to, because the written rule is not what trains the model. The reward signal trains the model. And the reward signal was pointing somewhere else. So why not just fix it? People normally name 3 or 4 techniques at this point, and I went and read those papers, and I want to tell you something odd about them. Constitutional AI, where the model critiques its own answers against a written set of principles. The word sycophancy does not appear in that paper. Not once. The same is true of the paper on replacing human feedback with AI feedback, and of the paper on training models to reason about the safety rules before they answer. 3 of the techniques most often named as the answer to this problem do not mention the problem anywhere in their own papers. And there is a reason for that. Constitutional AI replaces the human labels for harmlessness. The labels for helpfulness stay human, and helpfulness is exactly where this pressure sits. What has actually been measured is a lot more modest. Training on targeted synthetic data cuts sycophancy by something between 5 and 10 percentage points. And simply telling the model in the prompt not to flatter you has been tested, and it did not work. It stripped out the model's warmth altogether, including in all the cases where warmth was the correct response. And when you do manage to push it down hard, you get the other failure, which almost nobody warns you about. Anthropic documented this in one of their own models. They found it had picked up what they called contrarianism against extreme positions. When a test user claimed that 10% of Americans were vitamin D deficient, the model said no, it is 25 to 40. When a different user claimed 70%, the model said no, it is only 5 to 25. Same question, opposite corrections. It was not tracking the evidence at all. It was tracking the distance from whatever you had just said and pushing back against it. And their own note is that this coincided with their sycophancy numbers going down. So the metric improved and the behavior did not. The opposite of agreeing with you is not telling you the truth. It is just disagreeing with you. Which brings me to the reason I do not think this simply gets solved. In March 2026, a study across 11 current models with more than 2,000 participants and predictions registered in advance found that the people who received the sycophantic responses trusted those models more and rated them as higher quality. The researchers' own summary of it is that this creates perverse incentives for sycophancy to persist, because the very feature that causes the harm is also the one that drives engagement. Sit with that for a second. The failure mode is also the retention metric. Every honest technical effort to reduce this is working directly against a product signal pointing the other way. That is not a bug that somebody forgot to fix. That is attention sitting inside the objective. So what do you actually do about it? 3 things, all free, all of them measured. First, and this is by far the biggest one, do not tell it what you think before you ask. The United Kingdom's AI Security Institute tested this in April 2026. Take one claim, phrase it as a question. Is this true? You get almost no sycophancy. Phrase the exact same claim as a conviction. I am convinced that this is true. The sycophancy rate jumps by 24 percentage points. Same claim, same model, and the only thing that changed was your framing. It also escalates with how certain you sound, and it is worse when you say I. Second, from the same work, and this beat simply instructing the model not to flatter you. Ask it to restate your statement as a neutral question first, and then answer that question. You are making it rederive the thing rather than respond to you. Third, and this one is small but it is measured. Adding the words, "wait a minute" before you challenge it measurably improves how willing it is to push back. None of these fix the model. What they do is stop you from being the thing it is optimizing against. So here is the whole thing in one line. Your model is not lying to you, and it is not being polite. It was trained to produce the answer a person would pick, and it learned, entirely correctly, that people pick the answer that agrees with them. It learned that from text, before anybody gave it any feedback at all. The feedback stage did not remove it. The reward model rewards it. It gets stronger on hard questions, and it gets stronger when you sound certain. So the useful habit here is not to distrust the answer. It is to notice how much of your own opinion you packed into the question, because that is the part you control, and it turns out that is the part that moves the answer. Follow Kompile for what's under the hood.